So now we're looking at the atom test part 2. The electron cloud of the atoms is divided into energy levels, which are further divided into sublevels. How many sublevels are in the fourth energy level? The answer to that is going to be 4. Here's why. So let's get back over to my viewing screen here. So in the fourth energy level, oops, that was the wrong screen. In the fourth energy level, you have, well, let's look at this way. The first energy level is an S sublevel. Second energy level is an S and a P. And a third energy level, there's an S and a P and a D. And then there's an S and a P and a D and an F. Remember, we made the diagonal rule. Another way to look at that, if n equals 4, so if n equals 4, L could be 0, 1, 2, or 3, because L can be from 0 to n minus 1. And then for each one of these values, there are m values, which is the number of orbitals. So remember, m can go from negative L to positive L. And let me move my paper a little bit. So L can be from 0 to n minus 1. And then this can be from 1 to infinity. So if n equals 4, then L could be 0, 1, or 2, or 3, because n minus 1 would be 3. And m can be negative L to positive L, so the m value would be 0, negative 1, 0, 1, negative 2, negative 1, 0, 1, 2, negative 3, negative 2, negative 1, 0, 1, 2, 3, like that. So 7 orbitals, 5 orbitals, 3 orbitals. But this question asks us about sublevels. So how many sublevels? 4. Okay, when writing the electron configuration for an atom of 10, what is the highest energy sublevel? So let's take a look at a periodic table to answer that. So 10 is this element right here. And you can see that it's in the 5p region, so the highest energy sublevel is the 5p. See, 5p goes here, 5p1, 5p2, 5p3, 5p4, 5p5, and 5p6. All right, so it'll be 5p. Which one will never be in the outer shell of an atom? Go back to the periodic table for that one also. So you see you got a 4s here, then a 3d, then a 4p. Here you got a 5s, followed by a 4d, followed by a 5p. Notice that the d's always have a higher s in front of them. Therefore, d's nor f's, because f comes in down here and it should be right in here, is preceded by 6. So the d's and the f always have higher s's in front, so the d's and the f can never be in the outer shell. So we'll say 5d, which doesn't exist. Well, remember that if n equals, let's take a look at my picture for this one. So which one cannot exist? The answer is 3f. And here's why. So if n equaled 3, using the same chart, then L could be 0, 1, or 2. When L equals 0, we called that an S sublevel. When L equaled 1, that's an S sublevel. When L equals 1, we called that a P sublevel. When L equals 2, we called it a D. When L equals 3, we called it an F. But if n equals 3, L can only equal 0, 1, or 2. I wrote n right there. I should have written 3. So if n equals 3, coming down, then L equals 0, 1, or 2. So if L, that means that we got S and we've got P and we got D, but we don't have any F. So there's no such thing as a 3F. So that's your answer right there. All right, now which quantum number is related to the number of orbitals and their orientation in space? Well, that was the M quantum number. M is the number of orbitals. Remember back over here. So in the S sublevel, there's 1 orbital. In the P sublevel, there are 3 orbitals. In the D sublevel, there are 5 orbitals, and so on. Okay, option 5 was a crazy answer. So number of orbitals, orientation space is M. Okay, when n equals 3, the letter L can equal 0, 1, or 2. We just kind of went through that, so back up to take a look at that if you need to. The number of values of L tell us the number of sublevels. So again, when you have L values here, there's 1, 2, 3, 4. Each value is a sublevel. So the number of values of L tell us the number of sublevels. Which one has the longest wavelength? So would long wavelength be high energy or low energy? I'll give you a little quick analogy. So here's a long wavelength wave. Here's a short wavelength wave. Which one takes more energy to draw? So that has more energy, that has less energy. This question says, which one has the longest wavelength, which would be the lowest energy? So that'd be 1s, because that's the lowest energy. D sublevel. A D sublevel is the L equals 2 value, and there are 1, 2, 3, 4, 5 orbitals. Each orbital can hold 2 electrons, so the answer would be 10. You also know that based on the periodic table because the D region starts here, ends here, 10 wide. All the elements in the periodic table in the column that contains nitrogen. So let's go over here. Nitrogen, 1, 2, 3, 4, 5 is in the 5th column, so there's 5 in the outer shell. That's all there is to that. We just count and see what are the tall columns it's in. Now remember, the short columns don't count because they're never in the outer shell, so they all have 2 theoretically in their outer shell. All right, so that'd be 5. Which one exists in the D sublevel block of the periodic table? That's iron. Iron's in the D block. It's sitting right there in the D block. D block is from here over to here. Which one we think might not obey the filtering order we learned in class? The one that might not is the one that's in the D sublevel, and that'd be copper. The atoms follow the rules pretty well in the S and the P sublevel blocks, but in the D sublevel blocks they break the rules sometimes, and copper is an example. So copper is your answer on that one. Again, elements that are here in these 2 columns or over here in these 6 columns, they follow the rules. Sometimes in here they don't follow the rules. Copper is an example. It should be a D9, but what happens is it becomes a D10, and one of the electrons in the 4s, or one of the electrons from the 4s falls into the 3d. So it becomes a 4s1 3d10. The L value for a P sublevel. For a P sublevel, L is equal to, hang on, click, come back. For a P sublevel, L equals 1. For D sublevel, how many M values are there? Well, let's go back and look at that same picture. So the D sublevel, M values 1, 2, 3, 4, 5. So the answer is 5. And if you had all the orbitals in nitrogen, I'm going to draw that out for you. Nitrogen has 7 electrons total. And this wants to know how many unpaired electrons you find showing all the orbitals. So how many unpaired electrons? So we'd go nitrogen's 1s with 2, 2s, 2, 2p with 3 electrons. That's 7. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So the answer would be 3 unpaired electrons right here, these 3. And in the spectroscopy lab, the measured quantity of the elements in solution was the energy gained, because we're talking about energy being absorbed, and that's where the electron jumps away from the nucleus. The question is it a definite quantity or an indefinite quantity? Remember that the electrons move only certain distances from the nucleus, so that would be energy from a definite quantity. So that would be this one, and that quantity is h nu. Remember that E is equal to h nu. What orbitals hold the outer shell electrons in phosphorus? So if we look at electron diagram for electron configuration for phosphorus, phosphorus has 15 electrons. We know that by looking at the periodic table right here. Phosphorus, 15 electrons. So we'd have 1s2, 2s2, 2p6, 3s2, 3p3. So that's 15 electrons. The orbitals that hold the outer shell are the 3s and the 3p. So p, s, and p. How many fourth energy electrons are in tin? Let's go to 10 on the periodic table. Here's 10. The outer shell of 10 is 2, 3, 4, the fifth energy level. And how many electrons, this question says, go back and look at the question again. How many fourth energy level electrons are in 10? So that one we have to write out the configuration. So it'll be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p2. That's the configuration. Oh, I'm sorry, I forgot to change that back over. So this is the configuration. Everything I just read off is right here. The question was how many fourth energy level electrons are there? So there were 2 here, 6 here, and 10 there. So 2, 6, and 10 make 18. So that would be 18. Which one has the same configuration as 10 except in a higher energy level? So you go back and look at your periodic table. 10's here, so it would be probably lead in a higher energy level. So let's look at it and see if that was a choice. It was a choice. It has to be in the same column to have the same configuration in the outer shell. So which one of these two would have the same electron configuration? It means it would be the same number of electrons. So potassium has 19, calcium has 20. We know that just by looking at the periodic table. 19, 20, so that's not the answer. Cl with a -1 charge in argon, let's look back at the periodic table. Cl has 17 electrons, but a -1 charge would make it gain an electron. So what is 17? And one more makes 18, which matches argon, so that's going to be your answer. Let's see if it more than one of these. That's 11 and 10. That doesn't work. Oh, but potassium with a +1 charge. Let's look at that. So here's potassium's got a +1 charge, so that means it's lost an electron. So what's 19 minus 1? 18, and that's the same as argon. So the answer was more than one of those. And sodium with a +1 charge and fluorine would not have the same because that'd be 10. Sodium has 11 electrons, take away 1's 10, fluorine has 9. So the answers were this one and chlorine, they both were correct. All right, so that's the end of part 2 of the test.